Okay, I want to introduce you to some vocabulary. Most of the vocabulary is probably familiar to you, but we're going to do it in terms of calculus. So first of all, a horizontal tangent would be a place where if you found the tangent line, that the tangent line would be flat. For example, right here, it's hard to draw on there, right there would be a place where there's a horizontal tangent line. So basically what happens there is that the derivative equals 0, because the only way that you can get a horizontal tangent line like that is where the derivative is equal to 0. So if the question asks you find the horizontal tangents, you're going to find the first derivative and you're going to set it equal to 0. Critical points are special points, but basically it has to do with the derivative as well. It's where the derivative is equal to 0 or where the derivative is undefined. So we look for all the horizontal tangents, but also places where the derivative is undefined. Extrema is talking about relative maxes and mins. So maxes and mins that you found before. Absolute extrema is the actual max and min over the whole entire graph. So let's look at this graph. And we'll label some points here. This is A, B, C, and this is f of x. So first, if I wanted to find the horizontal tangents, or where the horizontal tangent lines would be located, they would be located anywhere where the derivative is 0. So only A is a place where the tangent line would be horizontal. If I wanted to find the critical points are any place where the derivative is 0 or undefined. So A, B, and C all have places where the derivative is undefined. If I wanted to know where any places of the relative max would occur, it's any places where there's a maximum around certain values. So x equals A and x equals C are places where there's a maximum. Relative min would be at x equals B. If it asks for absolute max is where the highest value is on the whole entire graph. It would occur at x equals C. The actual max is that y value right there, but I didn't label it, so we're just going to say it's at x equals C. There is no absolute min because this graph continues to go down and never levels off at a certain place to get to a certain value. So this particular graph has no absolute min. Alright, so what if we just have some equations? And equations are asking us to find critical points or find horizontal tangents. So the very first thing that we should do is find the derivative. If you think of this as 3x to the negative 1, that would be fine. So the derivative there would be negative 3x to the negative 2. Well, if we rewrite that, we would have negative 3 over x squared. Alright, if it asks for you to find the horizontal tangent lines, then the horizontal tangent lines, there would not be any. Because horizontal tangent lines is where the derivative is 0. The derivative is 0 when the top is equal to 0. Negative 3 never equals 0, so there's no horizontal tangent lines. Critical points would be where the top is 0, but also where the bottom is 0. So if I want to find the critical points, I'm going to set the bottom equal to 0 also, and I get x equals 0. So 0 is my only critical point, and there's no horizontal tangents. Okay, for the next 3 problems, I've already found the derivative for you, because I don't think we need to practice finding the derivative. But the problems you'll be given will be starting with f of x. So just know that you start with f of x. I'm going to ask you to find the derivative like I've already found, and then you're going to use the derivative to solve certain problems. So this particular problem, let's say that we wanted to find the horizontal tangent lines, we also wanted to find the critical points. So first of all, because this is the derivative, we take the derivative and we set the top equal to 0, and then we also set the bottom equal to 0. Alright, so on the first one, we're going to factor out an x. There will be some factoring involved. We get x equals 0 and x equals a half. And then if we solve where the bottom is equal to 0, we get x equals 0. So this is the horizontal tangent lines. There's horizontal tangent lines at 0 and a half. And critical points, 0 is already included as a critical point also. So critical points are at 0 and 1/2 as well. Remember that critical points are all these places. Horizontal tangent lines are only these. Okay, looking at this one, this is already the derivative, so I set the derivative equal to 0. Subtract 1. Divide by -2. And I'm looking for where cosine of x equals a half. You can use your calculator. If you use your calculator, you're going to do cosine inverse of a half. Your answer does need to be in radians, including pi. So if you need to do it in degrees first and then to change it, that would be okay. You should get the x equals pi over 3. And this particular value is a horizontal tangent and also a critical point. There are plenty more values, but at this point I'm just looking for the first one. Alright, this derivative looks really strange, and setting it equal to 0 sounds horrible, but I want to show you how to do it because it really isn't as difficult as it may seem. First thing that you would do here is to rewrite it. Bring that 1 minus t to the -1/2, bring it to the bottom. Like I said, I know it looks weird, but when we set it equal to 0, it won't be too crazy. Because when you set it equals 0, you'll move over that part of it. And we're going to cross multiply, so we'll do this side equals this side. So when I cross multiply the square roots, I end up with a negative and then 1 minus t, so that's -1 plus t. And then equals the other side that multiplies, so that's -t. Subtract t on both sides. Divide by -2. So we get t is a half. So from our horizontal tangent lines, there's one at t equals a half. Critical points, t equals a half is 1. But also any place where the derivative is undefined. Go back up here to look at this derivative. The derivative would be undefined anywhere where this value is equal to 0 because it's on the bottom. That would be at 1. So there's also a critical point at t equals 1. And really anything greater than 1, but probably this particular function would be defined as less than 1. So we'll go ahead and list the 1 as a place of the critical points.